Hello and welcome to today's webinar. Today's speaker is Catherine Absher. Catherine graduated from the Savannah College of Art and Design with a Bachelor of Fine Arts in Fashion Design, and she received her Master's of Science from NC State in Textiles. There, she studied inclusive design strategies and 3D prototyping. Catherine joined us here at Cotton Incorporated in 2020 as the manager of the Digital Product Creation Initiative.
Thank you so much. Thanks everyone for joining us for today's Digital Fabrics 101 webinar. In today's presentation, we're going to cover the what, why, and how of digital fabrics. We'll go over what is a digital fabric and at a high level, how are they created. We're going to discuss why brands should be using digital fabrics instead of continuing with traditional fashion design and sampling processes. And then we'll go over some ways that companies can begin to start using digital fabrics. So without any further ado, what is a digital fabric? So a digital fabric is a representation of a finished physical fabric that's used in 3D apparel design software. And you've probably heard of a number of these software options, such as CLO 3D, Browzwear, Optitex, Style 3D, and there are more. You may have heard them referred to as digital fabrics, digital twins, digital fabric twins, virtual fabrics, but they all mean the same thing. It's a type of file that recreates both the visual appearance and the drape of a physical fabric. And in this example, we're showing this fabric, which is a digitally printed mercerized Oxford. And on the left, we have a photograph of the finished physical fabric. And on the right, we have a rendering of the digital fabric. So we're going to see if this video will play for us. And I'm sorry if there's a slight lag, but this video will show the three main components of digital fabrics and how they're made. Essentially, digital fabrics are like a twin for the physical counterpart. It recreates the look and the drape of the physical fabric. We use a camera or a scanner to get a high quality image of the fabric. And then we use a physical testing kit to gather data on how it drapes and moves. And last, we consider the data storage and information that needs to be stored with the fabric for it to be ready to use. And you have a complete digital twin. Oh, we're going to go forward. There we go. So as we saw in the video, digital fabrics have three main components: the texture, the physics, and the data. And we'll go into a little bit more detail about each one of those. So a digital fabric's texture, it's actually a set of images. And like these. So here in this example, we have on the left, we have the 3D model with no texture applied. And then next we add the base or diffuse texture. When we add the normal map, we get a little bit of lighting information. And when we add the roughness map of this fabric, we see the shine properties that it has. When we finally add the transparency map, we can see that this fabric is actually a lace, and it actually has areas that are holes. So when you have a complete texture stack, you can really represent all the characteristics of that fabric in a digital environment. So how are digital fabrics scanned? The industry has three options at this point. And the first one is a high-end material scanner, such as a Vizoo or an X-Rite, which take images of fabrics using a DSLR camera. And these solutions often come complete with software to handle material tiling and the full texture creation. But they're not the only way to scan your fabrics. You could also use a flatbed scanner or a smartphone to get images of fabrics. And typically, when you use those two options, you also use a material creation platform or an art tool, such as Seti Textura, Swatch Book, Swatch On, or an art tool like Substance Designer by Adobe to help you process your scans into a complete material. The second component of digital fabrics are the fabric physics, which represent the fabric drape or the way the fabric hangs under its own weight. Fabric physics are critical to the realistic representation of a fabric in 3D. How are they measured? So in 3D software, measurements of the fabric's weight, thickness, bending, and stretching properties are taken. And these properties are tested at currently using testing kits that are proprietary to the 3D software. And it requires a warp, weft, and bias sample strip to be cut for each fabric and individually tested. Proprietary kits are a hindrance to digital product creation, but currently there's no other choice. In the future, the industry is looking for a more universal, standard, non-proprietary testing method for 3D physics properties, but at the moment, the testing kits are the main choice. And the last component in digital fabrics is the data. And by this, I mean that you'll need to consider both the information that might need to be stored with each fabric in your fabric library and how the data associated with your digital fabric will be stored. It's important where all this data is housed because it does take up a lot of space. And many brands might outsource that storage to a digital material management platform or a digital asset management system, a product information management system, or they might build an internal system, but it can be a lot for a company's internal system to handle. And this storage issue needs to be considered at the beginning of using digital fabrics. So when you have all three components, your textures, physics data, and your fabric information and data storage combined, your digital file is ready to use. And it can take up to 30 minutes, an hour, or sometimes more to create a digital fabric, depending on the properties of the fabric that you're testing. So next we'll be talking about why should brands use digital fabrics? And the top benefits of digital fabrics are that they help companies save time and money by enhancing the design process and reducing waste. So by using digital fabrics and 3D design software to replace some or all physical clothing samples, brands that are more advanced in DPC are able to have a reduction of traditional calendar lead times. They're able to make faster and more confident decisions, have more time to iterate, which can lead to overall better designs that are adopted at a higher rate than physical samples. And when companies start to use fewer physical samples, they can reduce consumption of raw materials, sample yardage, sales sample yardage, leading to a reduced shipping costs and lowered freight carbon footprint overall. And we'll go into some more detail about each of these elements. So we have a sample calendar, which is based on a traditional casual sportswear calendar, the traditional fashion calendar that I'm sure most of you are really familiar with. And in a traditional calendar, it could take over a year for styles to reach the market. First, line planning, then concept and design review and adoption, and then visual merchandising. All the way to point of sale. And a few things to just look at here. In line planning, traditionally, decisions are made about styles, colors, and SKU counts that's based on data that could be over a year old. And then the concept and design process can be a 3 to 6 month period for just the design process, followed by 8 to 12 weeks for sample review. So these longer lead times for sampling and design processes that are reliant on swatching and flat sketches, they can result in low adoption rates, sometimes as low as 20 to 40%. And ultimately, the styles that are hitting the stores a year later may not then match what customers want to buy. Compare that to this sample calendar, which is based off of brands that are forerunners in DPC, that understand how to use digital assets after 5 to 7 years of experience, where they're ordering far fewer physical samples, and they're able to incorporate all the cross-functional partners in their value chain, from design, tech design, raw materials, and merchandisers. All these partners understand the value of 3D assets, and they've built the trust to be able to use them. And that's what allows them to reduce this calendar from roughly 12 months down to roughly 6 months. Brands like this are much more advanced than most. They started testing in an easy category, and they're along the line to where they may only physically sample the really difficult products. So here, using digital product creation methods, planning can occur with live or much more recent data. And these shorter lead times, better design methods can help to reduce the length of time from concept to point of sale. And styles that are prototyped in 3D tend to have higher adoption rates, and we'll look at why in a few slides. But lead time savings is also a benefit from the mill's perspective. This information was provided to us by Gimli, which is a vertically integrated manufacturer of knit fabrics and garments. They produce over 60 million knit apparel products a year, mainly for major US retailers. Gimli works with both Clo3D and Browzwear, and they offer fabric digitalization for both systems. And they've shared with us here that they can produce a digital sample in about 14 days, whereas a physical sample takes them about 45 days. And if there's any significant changes on the first physical samples, a second, third, or fourth revised samples tend to be needed. And in these cases, digital sampling can help to reduce even more time from that process. Gimli tells us that traditionally, basic styles take them 1 to 2 physical styles, but for fashion items, it might be more like 3 to 4. For something more complicated to get to that approved style. But if customers are using 3D technology, they can generally reduce to 1 or 2 physical samples only. So now if we look at the benefits of digital product creation and digital fabrics in the design process, and it really helps having more of a visual design process with 3D technology. In the middle, we have our 2 fabrics that we'd like to use for this example style. And on the left, we have a traditional mill card, and on the right, we have our digital prototypes. And using traditional mill cards, where you have your fabric swatches, your proposed colorways, and then a flat sketch, teams have to visualize everything about that style, which can be why so many styles tend to get dropped. 3D samples do have that higher rate of adoption because there's less conceptualizing of what they will look like. Everyone can see the same thing at the same time and make changes in real time. Digital fabrics are also really helpful for testing and viewing prints. The 2 fabrics in this example have the same base fabric, but have 2 different digital print options applied. When you're using digital fabrics, it's very quick and easy to change print colors, experiment with the scale and the placement of that print, enabling the design team to get the look that they want with fewer samples and fewer lab dips. It's similarly very efficient to view graphics and placement of graphics with digital fabrics, which can help reduce strike-offs. You can get a really good visualization of what your graphic would look like, even if it has multiple materials, like this example, which shows fur, leather, foil, and cork. And another reason that why digital fabrics and 3D prototyping can enhance the design process and reduce lead times is because they can help brands and mills communicate more effectively. Gimli tells us that using the 3D collaboration and viewing platforms makes communicating with their customers much faster and easier. Looking at this case study in cost and sample reduction from a large US retailer. So their challenge was that their tech design and their raw materials teams were highly dependent on development samples and garment sampling. And the business directive was to reduce the number of samples by implementing 3D technologies. And they set metrics across their 8-year journey. And within the first couple of years, they were able to achieve a 30 to 50% sample reduction for in-store presentations and apparel and textile developing. The first department to reach zero physical sampling was the newborns and children's wear department, and their new goal is for other departments to follow. So if your company is thinking about moving into digital product creation, once one department is able to achieve zero samples, it does help to build trust. We kind of have it built into the industry where we think we need to see physical samples for everything. But when we have a win like this, it can help other departments to feel more comfortable with working in new ways. So overall, looking at the last benefit of digital fabrics, 3D clothing technology can contribute to a significant reduction of waste throughout the value chain. So overall, when we use fewer physical samples, it creates this knock-on effect of waste reduction throughout the value chain in all these different areas that we have listed. So creating multiple development and samples and salesman samples, different colorways, leads to a lot of leftover fabric where brands have to meet supplier MOQs and MCQs because mills have in place because they need to recreate the conditions of bulk production. But if the brand only needs some of this sample yardage, then they end up having to carry that excess fabric overhead, either by paying for storage or having to sell off, dispose of, or destroy that fabric, which is all waste. Then consider the reduction in shipping costs, reduction in emissions from not having to air as many samples from the factory to the brand, having fewer dropped and added styles, and reduced times where the brand might need to send teams to visit overseas factories and mills. Regarding unsold clothing and reduced customer returns, 3D clothing technology can help reduce both by enabling brands to plan better with more recent information, with shorter lead times, allowing them to pivot more quickly if changes need to be made. 3D assets have also been shown to reduce returns because the customer can get a little bit better understanding of the product they're looking at before they buy it. So with some development in the area of digital product creation, companies can make real reductions in waste. So how could brands begin using digital fabrics? We'll discuss 3 different pathways that you could take. If you are new to this area, how could you begin to start using digital fabrics? And the first option would be to digitalize your fabrics in-house. Second, working with mills, vendors, and factories. And last, outsourcing to a digitalization service. The 2 that might be easier to start with could be to work with your vendors or to outsource, because there are benefits to not taking it all on internally anymore. An industry has grown around digital fabric creation that didn't exist even 5 to 7 years ago. Most companies working 7 to 10 years ago with digital product creation had to bring all their digitalization in-house, but now there are a lot of third parties that can help facilitate digitalization and digital material collaboration and storage. So if you were going to digitalize fabrics in-house, remember the 3 main components of our digital fabrics. So if you wanted to do this, if your company wanted to do this themselves, you would need to first consider your fabric textures. You would need to determine how you're going to obtain your fabric scans. Remembering your scanning options would be a high-end material scanner or a flatbed scanner or a smartphone, plus a way to process images into a finished tiled digital material. And then you'll need to consider your fabric physics. And that's right now going to be dependent on your 3D software options. So your software is going to be determining what your testing solution would be. And then last, you need to consider finding a solution for managing, sharing, storing digital files and data that will integrate with your other internal systems and software. The second pathway, digitalizing fabrics with mills, is also a great way of getting started using digital fabrics. Many mills are up to speed with digital prototyping and with digitalizing fabrics. This example, physical and digital samples, comes from Gimli, and they invest a lot in research and development and new technologies. Not only are they using CLO and Browzwear, they're also a qualified technology supplier for trans-dry, storm cotton, and tough cotton. So these days, mills are increasingly becoming not just suppliers, but technology partners. And partnering with mills that have invested in this technology could help your company on moving into the digital space more efficiently, because they can lean on the mill's experience more. And those trusted mill partners that are more advanced, they also have experience with other brands, so they could help you to implement 3D faster. And the third way that companies could begin using digital fabrics would be to outsource digitalization to a third-party service. And there are various services available now that are relatively new but very robust. Some offer full-service fabric digitalization. Others can enable your company to scale fabric digitalization in-house. Generally, they include an option for more of a platform option to help with the storage, the management, collaboration, recoloring or editing of digital materials. And they tend to work across 3D software programs with various integrations. So you don't have to do it all yourself. And if you're trying to decide how to move into using digital fabrics, you can visit us at cottonworks.com, the go-to resource for all things cotton and education. You may know Cottonworks already, but we offer a free digital fabric library of cotton and cotton-rich fabrics for designers, students, brands, and anyone using 3D software for garment development. To access our fabrics, navigate to Cottonworks, the Resources tab, and then select the Fabricast collection from the menu. And you can browse through our collection of over 300 digital fabrics compatible with CLO and Browzwear. If you are a V-Stitcher user, you can find our collection of 30 more sustainable and minimally processed fabrics in the Cottonworks Fabric Library. It's built right into the system. So be sure to check that out if you are a V-Stitcher user. Linked, we have our page on Cottonworks announcing the collaboration, and there's also a page on browzwear.com about our more sustainable collection there. For slightly more advanced users who are interested in the Adobe Substance 3D Suite, which is an ecosystem of apps and content for 3D design and materials, check out the Substance by Cottonworks collection, which is a small collection of fabric textures recreated in Adobe Substance Designer, which is a 3D material authoring tool. And you can download these files for free and import them into CLO and Browzwear to see what you could do with the Substance tool set. Here we have the YouTube link here is to our video launch with the Interline and Adobe Substance. And then you can actually access these assets on substance3d.adobe.com.
So with that, I'm going to conclude today's webinar, and again, visit cottonworks.com. Thank you everyone for attending.